because H is the first letter in the string, right? And then you can also run the same length operation on it. So you can say length, the word hello is 5. That all makes sense. You can add two strings together. You can do this and you'll get hello world. You can also do that with the variables. So, same story there. Can you all see this? Is this too small for someone? Okay, great. What happens when I do this? So I'm trying to add, okay, I'll run this line. What happens when I run the line that I'm going to run now? 11 world. Okay, let's try that. Great. So you can. So what the str function did was it took the number 11, which so A had the number 11, which is a type integer, right? And then when you wrap it with str, that pretty much tells Python that you want to treat that, you want to convert that that number, that integer into a character or a string in this case. And so when it's a string, you can then append it to the other string world. So if I take this out and do that, what do you think I would get now? What kind of error would it be? Yeah. So in Python, these are called type errors because you try combining something, a type int with a type string. So make sure you because so unlike Java and other languages, Python is not very explicit about types. It's very implicit. So it'll assign the type of whatever you give it to. So if you give it the number 11, it'll automatically infer type int and assign it to that. So you want to be careful with your types when you're doing homeworks and stuff. It will yell at you about it, so it's not something that you can easily slip up on. But keep in mind. Right, so this is just converting the number 10 to string. Let's look at this function here. So what is this trying to do? You can you can either take a minute to look through it, or you can just read the name of the function. You should know what it's doing. Sum values. So what should the value of sum be? Do some quick math here. Fill it out. 13. What else? Okay, great. You made it this far in life, so you should know that this is in fact going to be 15. All right. That would be 5 plus 4 plus 3 plus 2. All right. So that's kind of what it's doing is it's adding to the variable sum the value that it finds at this index in the list my list. So it goes through each one of these things and it does it. So who can tell me what is a better way to write this program, and one that doesn't take as many lines? For loop, awesome. So yeah, it says it right here. The exact same, you can rewrite the exact same program to do what you want in just 2 lines using a loop. So we could run this. So this is taking every number from the range 0 to 10. So to make it more explicit, what you can do is give it that, and then it'll tell you can give it a start and an end, or you can just leave the start and you'll assume that it's 0. So it printed every number basically in the range of 0 to 10. So I can run it again with 5, 6, 7, 8, 9. So it doesn't include the number at the end because 10 is the upper bound. It doesn't want you to print that. So any questions about this so far? Okay, great. What is this going to do? It's pretty easy. You should know just by reading it that. So Python is great because a lot of the things that you can do with it are basically like how you would say them in English. there's not a lot of syntax. So like this one, the second line just says for element in the list, print the element, right? So all it does is print the list that there is up there. You know, pretty simple. All right, let's go through one final example. So I'll actually let you guys take some more time and figure out what's going on here, because this is a little bit tricky. But if someone figures it out, then... Actually, you know what? I'll have one of you guys explain it. So if you figure it out and you want to come and explain it to everyone, raise your hand and you can come down and do it. You know it? All right, come on down. Go for it, dude. Who else thinks pineapple should go on pizza? Wow. Wow. Okay.
Okay, hello everyone. So when you call this function list underscore sum, parentheses, that's like calling the function. So then it goes up to that function that's defined up there, and it's going to run it. So I guess we'll just walk through it line by line. So on the first line we have a list called I with 4 elements. List is 1, 2, 7, 4. Then you have a variable that's initialized called sum, and you set equal to 0. Then you have another list called food. You put in 4 things in there: pizza, lettuce, onion, and pineapple. Those are all strings. So now you have your 2 lists and your sum variable. So now you run your first for loop. So for j in range 0, len I. So what does this mean? We'll start with j. J is going to assume it's going to be like initialized as an integer. So when you run from range 0 to len I, what's len I? Anyone? Come on guys, help me out here. 4? Yeah, there you go. So you have kind of like a, from range 0 to 4, that means as this for loop iterates, it's going to go from j equals 0 to j equals 3. Kind of like in CS 125, we're learning for loops. I kind of already learned it, but it's like the whole like for int I equals 0, semicolon, I less than len I plus plus. That's exactly what this is. So here's your for loop. So it's going to iterate 4 times. And so each time j increases from 0 to what number? Someone shout it out. 3, yeah. Again, that's because like, that's kind of how these CS people do their thing, right? They're like, you go up to 10, it's really like you go up to 9, because they just like to mess with you like that. So j is going to start off as 0. So when you write I bracket 0, you're calling the 0th index of the I list. So what's the 0th index of the I list? 1. There you go. So sum plus equals 1. What's 0 plus 1? There you go. Now, when you call I j, but j now increases to 1, what's the first index of I? Oh wow, look at you guys. There you go. So sum increases by 2. So then you can kind of imagine it just runs through the entire list. You get 1 plus 2 plus 7 plus 4. What's that? Come on, somebody. 14. There you go. So now it prints sum, which is 14. That's your first part. Now you go on to the next for loop. So for item and food, for those of you who are learning Java right now, or who know Java, or have only learned Java so far, this is a little bit confusing, but how it works in Python is you can write something like for item and food, and then whatever, oh, come on, man. Why do you do this? So, yeah, it'll like initialize to, wait, actually no, I'm confused. It just maybe just doesn't. It just prints the list, right? Yeah, because it doesn't. Yeah. So I did not explain that very well, but yeah.
All right, so yeah, I just changed it at the end to be very assertive about the fact that pineapple is not going. But all right, so yeah, that's exactly right. A good explanation. It prints 1 plus 2 plus 7 plus 4 plus four, right? Yeah. And then just the string pineapple does not contain. So if I had to print what was on here before, which was like like pizza and tomatoes and whatever, it would inline print each one of those things. And awesome. Questions? Change the type once to declare it. Great question. Do you think? What do you guys think? So he wants to say. Right. So what? Okay. What would sum be at the end? Is that what you want to know? Does this code even run? No. Because why does it not run? Adding numbers to a string, right? So, but what does that tell you? That tells you that you did in fact change the type of sum, and you did make it a string. Does that answer your question?
If you're going through a list and then the types of things down this string, then that variable needs to be like.
What do you mean? So you mean like?
So like if you had a list that's like 4 items in view, but you had numbers and strings.
Got it.
Then item is the string type.
Item can change type. So the item variable will pretty much change with every string that it goes or every element in the list that it goes through. Yeah. So if you had to print the type of item for everything that it moved through, then it would print it. So we can try that. So we could do this and then check this out. And I think it's right there. Oh yeah, okay. Great find. Who wants to tell me what I did wrong? Like, why is this code not running? Why is there a type error here? I reset sum to 0, right? And it still doesn't want to run. Why? Yell it out if you think you know it. Nobody? Let's try that again. So I have this variable sum that I initialized to 0, right? And then I'm scanning through it here, and I'm adding I of j, so I of, so it's going to loop through 1, 2, 7, 4, add that, and print sum. Why should it not work? Because I forgot to run that block. So I just called this sum on the previous one. All right, cool. So to answer your question though, it prints the type of each individual element in the list. So I print string for the first one and then int for the number after it. Is that all good? Awesome, cool. So yeah, homework will be released tonight, 10 o'clock. It will cover like pretty much all this stuff, and it will still be on Relate. Expect it to be not very easy, but easy enough. So office hours, we will have our office hours on Friday and Monday. I believe it's 5 to 7 on Friday, and then 6 to 8 on Monday. So if you need help, one of us. But cool. So.
Okay, so next we're going to have an NLP micro lecture given by one of our staff members, Aiden.
Go in.
So April Fools, it's not actually an NLP lecture. Hi guys. My name is Aiden, and today I'm going to be presenting on functional programming. So first of all, I'm just going to ask a question. Do any of you guys know what functional programming is? That looks like around 3. Okay, it's better than 0, I suppose. But yeah. So essentially there's 2 main types of programming. One is imperative programming, and one is functional programming. So the first thing I'm going to say is Vivek just taught you how to do imperative programming, and what I'm going to tell you is imperative programming isn't very fun in my opinion. So forget everything that you know. So yeah. So the differences between imperative programming and functional programming. So one thing that you don't see in imperative programming very often is something which is called passing functions into other functions. So normally when you have a function in an imperative language, you might pass in like objects or like strings or like doubles or integers. But in a functional language, you can actually pass functions into other functions. So yeah, so that's the important bits. So how many of you guys know how to write Java code? Okay, cool. So in Java, you can do something like, let's say we have a class or an object which is called robot, right? We can say maybe, what do you want to name the robot? Can someone give me a name for robot? Someone said Ron, I think. So let's say our robot is called Ron. So what we can do is we can say robot Ron equals new robot, right? And then maybe if we have a function which figures out what the size of the robot is, like get size. So let me write that out. So maybe cool. Can you guys hear me? Nice. Okay, cool. So yeah, so you might do something like robot Ron, or you might do something like robot Ron equals new robot, and then you might pass Ron into some function. So maybe your function is called getSize. So you could do getSize on Ron. But something else that you might not see as often, but is still pretty often, you still see pretty often, is you can actually make a new robot inside the function itself. So you can say something like new robot, and then maybe it takes in a size parameter for the constructor, and then that would return 10. So is everyone following so far? Yes. Cool. So anonymous functions are pretty much the equivalent of that, but for functions. So normally when you define a function, you do def, the name of the function, and then whatever the contents of the function is, right? But essentially, anonymous functions are just a way of making a function without a name. So let me show you an example of that. So let's say we have our basic add function. What we could do is we can do def add, and then we could do x and then y, and then we could just return x plus y. And then hopefully, if we're not terribly bad, yeah, we get 7, right? Cool. But if we have an anonymous function, what we can do is we can use this weird syntax called lambda. Don't ask me why they're called lambda functions. And then we can essentially do the same thing. will also get excited. So as you can see, we essentially made a function, but we never gave it a name. And we can essentially do this with any function that we want. And the reason why we'd want to do this is if we only want to use a function for like a one-time use, we can use this special syntax, which will make us a one-time use function. And it's easier than having to write out an entire function definition. Are there any questions so far? Yeah. Why is that better than just replacing them? Could you say it again? Oh, yeah. So in more advanced examples, it'll make sense. Yeah. Are there any other questions? Yeah. If I remember correctly, lambda functions in Python have to all be written in one line. So I think the answer is only one. Yeah? Are there any other questions? Okay, cool. So back to the question of why you would want to actually use this weird syntax rather than just writing 2 times whatever. So essentially, the reason why is these things called higher order functions. So as I was saying before, what we can do is we can pass functions into other functions in Python. And here's an example of that. So we have a function which is called map, and then we can pass in a lambda function, so an anonymous function, and then we can use that function within our other function. So I'm going to put up this code in the Slack, hopefully, if this works. Everyone has access to Slack, right? Yes? Raise your hand if you have access to Slack. Okay, cool, nice. Oh, really? We will do something else. We will just paste it.
Put it in random.
Put it in random? Okay, sure. Okay, so you can copy this into whatever Python editor of choice you want to use, and then we should be able to do some demo code. Cool. Cool. Have you guys copied into like whatever editor of choice you want to use yet? No? Okay. I can wait longer.
Idle itself. Except no alternative. Yeah. Named after Eric Idle, one of the people from Monty Python.
He's just doing runs and stuff. He's just doing the runs.
Oh, really?
Yeah.
I'd say I know that exactly.
It's like 5 minutes since yesterday, I think.
Have you? Okay.
Cool. Have you guys copied it now?
Keeps crashing.
Okay.
Just try the idle while I'm actually.
How do you copy again? Control C, Control V. Okay, cool. There's also a right click. Bye. Okay, cool. So yeah, let me explain what the map function is. So essentially what it does is Vivek did you talk about lists, Vivek? Okay, cool. So Vivek talked to you guys about lists. And essentially what map allows you to do is to run a transformation over a list. So what exactly do I mean by a transformation? Essentially all it is I'm going to apply some function to every single element in my list. So let me show you what that could look like. So it's called map, right? So let's say I have a list called L, and it has some numbers in it. Maybe 1, 2, 3, 4, and 5. Cool. So essentially what map lets me do is run some transformation on my list. So oh, 2 L's. Okay, can anyone tell me what they think that the result of this function call is going to be? I can't hear you guys. You think it's going to be 2 to each element? I don't think it's going to be 2 for every single element. 2 what? Does anyone know, think that they know what the answer is going to be? No one knows? 2, 4, 6, 8. Yes, that is it. But not exactly. So essentially, in Python, there's like these magical things called iterators, which, will someone cover that at some point? Next week. So iterators will be covered next week, but for now, let's just pretend as though they don't exist. So what we're going to do is we're just going to wrap this in a list call. So we're going to take our magical iterator and convert it back into a list. And we do get the desired result of 2, 4, 6, 8, 10. Cool. So does everyone follow so far? Are there any questions? Yes?
Does that edit the value of L?
No, it does not. If we look at the value of L, it is exactly the same as it was before. Yes. Are there any other questions? Yes. Is map the what? Oh, is map the new list? No, map is a function. If we wanted to save it to a new list, we would have to save it somewhere like, maybe we'll call it L2, and then save the result. And then now if we look at L2, we'll get 2, 4, 6, 8, 10. Cool. Is everyone good? Cool. So let's go into the first exercise. Well, actually first, we haven't really covered objects, so let me go like very briefly into what a tuple and an object is. So you guys all know what lists are. Tuples are pretty much just lists, but even easier. So a tuple is pretty much the same syntax as a list, except we're going to use these parentheses instead. And you can access them in the same way as a list. So if we look at 0, we're going to get 1. If we look at 1, we'll get 2. If we look at 2, we'll get 3. Does that make sense so far? Cool. And also, in regards to objects, the way the declarations work, or not declarations, sorry, the way initialization of an object works is it's really, really simple. In Java, you have to use this really annoying new keyword. In Python, we say we don't like writing new, so we just literally just put the arguments of the constructor into the name of the object. So if the object is called robot, and maybe it's a 2-argument constructor with some size and some name, that's all we have to do. And that will essentially construct a robot for us. So cool. So the first exercise I want to do is build robots. So I've already written the robot class for you guys, so all you have to do is use the quote-unquote constructor. Yes? The difference between a tuple and a list. So the only difference is in lists, you can modify lists, but tuples, you can't modify them. So for example, let's say I do L equals 1, 2, 3. And then I say L of 0 equals 5. You see L equals 5, 2, 3, right? But if I declared a tuple instead, then I said T of 0 equals 5, it gives me a very unhappy error. So that's the main difference. Sometimes we don't want to have sometimes we don't want to have lists which can change their size or change the objects. So in this case, actually I should explain this now. So in general in functional programming, it's considered good practice not to modify your previous variables, because that makes people unhappy. Because the basic idea is once you've declared something once, you don't want it to change, so you know what the value of it is. So whenever we want to make changes to a previous thing, essentially what we do is we make a new object, which is a slightly modified copy of the old object. So for example, that's back to the usage of map. Instead of modifying our original list, we're going to do a map over it and then create a new list rather than modifying the old list. Yeah. Cool. So have you guys had a chance to work on the first function, which is build robots? Yes? Cool. Does anyone want to tell me how you would go about writing this function? No? Okay, that's okay. We can go through it together. Okay, nice. So let me bring up my handy dandy text editor. I used Sublime. Don't worry, I'm not that bad. Okay, so we have build robots. So first of all, can someone tell me what is the function that I just taught you guys how to use and probably I'm going to use in this function? What? Yes, we're going to use map. Good idea. Okay, cool. So yeah, the weird iterator thing, we're going to have to wrap it in list. Okay, so we're going to make a lambda function, which is going to take in a single argument, which is going to be r. And oh, sorry, not r. It's going to be t, because it's going to be a tuple of 3 elements. And then we want to take this tuple and build a robot out of it. So can someone tell me how you think that we're going to write this function? Anyone? Yes. Yes, correct. Yeah.
You could use like the robot constructor function, so it'd be like robot and then the element T.
Okay, what do you mean by the elements of T?
Like T bracket 0, T bracket 1, and T bracket 2. And then those are, or maybe Python is totally different.
I don't think there is a way to do it, but I'm not going to talk about it because that will get confusing. Yeah, so we can essentially just say we want to get the first element of the tuple, the second element of the tuple, and the third element of the tuple, and then just pass those 3 arguments into the constructor, and then that will build our object for us. And I did not write the word map there, so this is bad. And then of course, we need to know what we're mapping over, so we're going to add in our list. And if we're lucky, yes, we get a bunch of robots in a list, which is what we expect. Cool. Does anyone have any questions so far? Sure, no problem. Are there any questions about it, or are you good? Cool. Should I move on? Sure. So let's start off by let's ignore this thing. That's kind of irrelevant. So first thing is we have the very start of it, which is map. So that's just the function which is going to take our old list and turn it into a table, right? Okay. The next part of the line is one of those anonymous functions. So that's just like a function which doesn't have a name. On the left side, we have the parameters that it takes in. And on the right side, we have what the return value is going to be. So it's going to take in a single parameter, which is going to be the tuple. And then on the right side, we have the return value, which is going to be a new robot based on that tuple. And then third, we just have to pass in our list with that map. And then again, as I was saying, the list thing around it isn't very important. Essentially, map returns like this iterator thing, and then we're just going to turn the iterator into a list. Correct, yeah. Yes.
So what's the advantage of doing this way instead of using a for loop to go through all the elements, like all of the robot characteristics, and then just adding the robot to it?
So this is one line here. The alternative would be this. So we would first have to declare a new list, right? Then we would have to for loop through robots. So for R in robot, or sorry, for R in robots. Then we would have to finally do L dot append. You get the idea here. And then finally you would have to return L, right? So the equivalent statement would be 1, 2, 3, 4 lines when you can actually do it in one line. And additionally, in my opinion, it's a little bit jank to have to like keep appending to a list. It's a lot nicer to be able to do it cleanly in just like essentially one fell swoop, I guess. So that was, yeah. Do you have another question?
The comma robot does the appending to the list, right?
The comma.
In the lambda, in line 26?
Yeah.
Yeah.
Oh, not exactly. So essentially, map just takes in 2 arguments. So the first argument is the lambda function, which you're going to apply to all the elements. And the second argument is the one that you're applying it over. So it's in this case, it's still robots. So it's not. So L would be like our target. It's like where we're trying to build the new robots into. And robots was our original source, which is where the tuples come from. So robots in this case is like the source, which is where the tuples come from. Does that make sense? Yes.
Is this any faster
Than the for loop? Probably about the same speed. Yeah. When you go into 173 and you learn about big O, they're both big O of n. I believe there's a slight advantage, which goes back to iterators, so I'm not going to talk about it. But the TLDR is, in certain circumstances, you can do less work if you don't actually need to do work. But if you want to know more about that, you can ask me after class. Cool. Are there any other questions? Okay, guys. So we just learned about map, so that was cool. And let's learn about filter. So filter is essentially another similar function, which is going to take in a lambda function as well as a list. So this is pretty similar to map, except for map, what we were doing is we were taking normally a list of size, let's say size n, and then we were also returning a new list of size n. So in the last case, we had originally a list of tuples, which was maybe like size 5, and then we returned a new list of robots, which was also size 5. So, but for filter, the idea is that we want to get rid of some of the elements that was in our original list. So for example, maybe if we have a list of a bunch of numbers, we want to know which ones are positive and which ones are negative. We could just, for example, keep all the ones which are like greater than 0. So let me show you an example. Okay, let's actually say greater than 5 or less than 5. So we can, I think we have to get import contour. Oh, right, iterators. So as you can see, the only 2 elements left in our list are the 2 which were bigger than 3. So it's a very similar syntax as before. We do the same cast into a list. We have a function first, and then we pass in the list as well. Does anyone have any questions on filter? No? Okay. I'm going to quickly go through the first one of the demo. So let's do only red robots this time. So essentially we're given a list of robots, which was using our class, and then we want to only keep the red robots. So does anyone have any ideas on how we might be able to implement this? Yes, use filter. Good. Okay, we'll start with filter. I'll give you a hint. We'll add the list at the front too. Okay, so we have lambda, r. Okay, can anyone guess what the context, or sorry, what the content of the lambda function should be? What'd you say? R dot color? And then what? Equal red. And then what is the thing we're missing? Correct.
Should it not include it if it's filtered?
I don't even know how it's supposed to be.
Works. Oh, right.
No, filters beyond.
Gets like one.
And yep, we kept only the red robots and did not leave any of the robots with other colors. So yeah, we're almost done with time. So I'm gonna let you guys go. If you have any more questions, feel free to ask me. I'll be here for a few minutes. Cool, thanks so much.
How many lectures?
I think also the semester.
No, like how many like individual lectures are there? Three.
They usually go to 9 points.
Alright, cool. You are actually free to go. We're not going to keep you longer. But if you were one of the people that raised your hand about not being in a project, or not having a group, or not knowing what a project is, or not knowing what this class is, come see us. We'll help you figure that out.
Alright, see you. Thanks, see you.
There's no attendance for today, because a whole bunch of people yelled at me for last lunch about the exam policy, so you're all marked as like being here.